Hi class, in this video what I want to do is I want to show you how to evaluate a double integral over a rectangular region. So here's the problem. I want to evaluate the double integral of 4xy squared over the rectangular region. So this dA tells us over what area. So the rectangular region, the x coordinate is going to vary from 2 to 4 and the y coordinate is going to vary from 1 to 2. Okay, so this is our bound of integration for the x variable, and this will be our bound of integration for the y variable. So here's how we're going to set this up. We're going to remove this r and put in our bounds of integration. So the first thing I'm going to do here, and you don't always have to do dx dy, okay, it really depends on the problem. But so I'm going to start with the integrating the x variable first. So I'm going to put the 2 to 4 here as the first bound of integration. And then I want to integrate with respect to the y variable next. So I'm going to put the y values 1 to 2 here. So doing these double integrals are incredibly easy. So when you're going to integrate this first part with respect to x, all you're going to have to do is treat the y variable as a constant. So you just have to integrate this 4x. Well, that's going to integrate incredibly simply as 2x squared. Okay. Now what I have to do is I have to plug in my bounds of integration 2 to 4. So you'll just use the fundamental theorem of calculus here to plug this in for x, not for y. Y is still held constant. So you're going to plug the 4 in over here, you're going to plug the 2 in over here, and you're going to subtract just using the fundamental theorem of calculus. This will then integrate as the following, or not integrate, this will then simplify to the following. You're going to have the integral from 1 to 2. This cleans up to be 24y squared. Now you're going to integrate with respect to y. So now this just gets back to a Calc 1 integral. So this integrates to be 8y cubed. You're going to evaluate from the bounds of integration from 1 to 2. When you plug these into this, you end up getting 64 minus 8, which equals 54. So this was a very, very simple example. All we wanted to do here was just remember, in this step here, when you integrate with respect to x, you're going to hold y constant. And then if you were to do it the other way around, if you were to do dy dx, you'd end up getting the same value, but you would just hold when you integrate first with y, you just hold x constant.